This short video we're going to talk about similar figures and more precisely similar polygons. So polygons are said to be similar if the corresponding angles are congruent and the side lengths have corresponding proportions. In other words, the proportions between the sides, the corresponding sides, are congruent. So here I have a little diagram of a quadrilateral. So I have all corresponding angles marked congruent, and then when I find the ratios of the corresponding sides, they're all going to be congruent. Therefore, they're similar. So similar polygons have to be the same shape, corresponding angles must be congruent, corresponding sides must have all the same ratio, and you're always going to compare longest side to longest side and shortest side to shortest side. So with similarity in polygons, you have a scale factor, which is the ratio between the two figures. It's a linear measurement. So this symbol right here, remember the squiggly means similar. So since I tell you they're similar, you know that the ratios are congruent. And you always compare longest to longest. We have all angles congruent, therefore we're going to compare the 25 to the longest side over here, which is 10. We got to make sure it's the same as the 20 compared to the 8 and the 15 to the 6. So when we reduce 25 over 10, we get 5 halves. Reduce 20 over 8, we still get 5 halves. And 5 halves. So the scale factor is just our ratio between the two figures is 5 halves, which means the bigger shape is 5 halves more times bigger than the small. Next, they're telling us similarity, and they want to know what pair of angles are congruent. So you got to look. M goes with S, so we know that angle M is congruent to angle S. We know that N goes with R. Remember, corresponding means same position, same location. So N goes with angle R, and angle P is congruent to angle T. So we know that M, let's mark up M, goes with S, N goes with R, and then that means P goes with T. What is the extended proportion for the side lengths? So in this case, if we're doing extended ratios for the side lengths, we would have MN over SR, we would have NP over RT, and then PM over TS. So I just use the same positions correspondingly to get my extended ratio or extended proportion. So let's apply this. We want to identify the pairs of congruent angles, so we know that U and K, T and J, MW, LV are correspondingly congruent. Next, we have to find if the ratios are the same for each corresponding side. And if so, what's the scale factor? So I'm going to compare 6 over 12. Is it going to be the same as 6 over 6? Is it going to be the same as 14 over 24? And then we have 16 over 24. So 6 is a half. This is 1. Here we have 14 over 24, which is 7. 2 goes into 14 7 times, 12s. And then we have 8 goes into 16 twice, 2/3. So notice they are not the same. not congruent, therefore we don't have similar figures. Why? Because of different proportions. So you might have figures within figures, and they tell you they are similar. So if you know they're similar, you know all angles are congruent, you know the side lengths are congruent. So I'm going to redraw the two shapes. Again, it doesn't have to be accurate. This is X, this is Y, this is 6. We have the bigger one. This is 9, 5, and 7.5. So when you start solving for a variables, you want to set up a proportion with the two sides that are corresponding without variables. So these two sides are corresponding without variables, so I'm going to do 6 over 9, and it's y over 5, which equals x over 7.5. So to solve, it's 6 over 9 equals y over 5. 6 over 9 equals x over 7.5. So when you cross multiply, you have 9y equals 30 divided by 9 divided by 9. Then you have 30 divided by 9, which is 10/3. So y equals 10/3. Next you have 6 times 7.5, and you're dividing by 9, and you get 5, and x equals 5. Our scale factor was 6 over 9, which is 2/3. Here they're asking to see if the polygons are similar. If so, find the value of each variable. So this angle congruent to that angle. We have another corresponding, therefore we have a third one because of vertical angles. So let's find out if they can be congruent. Well, we know that the polygons are similar, so that means the angles are congruent, and therefore the side ratios are the same. So how do we know which sides to match up? Well, longest to longest, short to short. Well, since you might say, well, we don't know what x and y is, how do we know which one's long and short? Well, here we're going to use our angles. So the angle that's opposite the one tick mark is 25.5. The angle that's, or the side that's opposite the one tick mark angle is x. So then we have the 37, which is the 2 tick mark angle. The 2 tick mark angle is y. Therefore we have 30, which will be over 15. To solve, you always use the proportion or the ratio that does not have variables. So 25.5 over x, cross multiply. So you do 15 times 25.5 and divide by 30. X equals 12.75. And you also use 30 over 15 equals 37 over y. So you have 15 times 37 divided by 30, 18.5. And our scale factor is 2. Which means you could do a short version instead of using cross multiplication. Since our scale factor is 2, we know that the big triangle is 2 times bigger than the small. So if we wanted, all we have to do is divide 25.5 in half to get 12.75, and divide 37 in half to get 18.5, and we still get the same answers. If you have any questions, shoot me an email or see me after class.